For over 160 million years, dinosaurs reigned supreme over our planet, populating every continent and occupying every ecological niche. The Cretaceous period marked the pinnacle of these extraordinary creatures, which had evolved into an incredible diversity of forms, sizes, and lifestyles. Vast herds of herbivorous hadrosaurs and ceratopsians roamed the plains, while fearsome tyrannosaurs stood at the apex of the food chain. In the oceans, colossal mosasaurs and plesiosaurs held dominion, and in the skies, pterosaurs soared with wingspans reaching up to 12 meters. It seemed nothing could challenge the might of these ancient reptiles, who had firmly established themselves as the rulers of planet Earth. However, approximately 66 million years ago, a cataclysmic event forever altered the face of our world and the course of evolution. Long before the infamous asteroid impact, a massive volcanic activity began in the region now known as India, an event known as the Deccan Traps eruptions. These monumental outpourings of basaltic lava persisted for several 100,000 years, blanketing vast areas with molten rock. The Deccan Traps released enormous quantities of carbon dioxide, sulfur compounds, and toxic substances into the atmosphere, poisoning the air of the planet. The resulting lava flows eventually covered more than 500,000 square kilometers, with basalt layers reaching up to 2 kilometers in thickness. The volcanic gases triggered acid rains, which decimated vegetation and acidified ocean waters, disrupting fragile food chains. The planet's temperature began to fluctuate, creating unstable climatic conditions to which many animal species could not quickly adapt. Some scientists believe that the Deccan volcanism was the primary cause of the extinction event, weakening Earth's ecosystems long before the asteroid's impact. Others argue that volcanic activity merely set the stage for disaster, rendering the biosphere especially vulnerable to external shocks. Paleontological evidence shows that even hundreds of thousands of years before the asteroid's arrival, the diversity of certain animal groups was already in decline. Ammonites, belemnites, and some bivalve mollusks faced severe pressure due to changes in the ocean's chemical composition. Yet, dinosaurs as a whole continued to thrive, with their populations remaining relatively stable until the cosmic catastrophe. The Chicxulub asteroid, measuring between 10 to 15 kilometers in diameter, hurtled toward Earth at a speed of approximately 20 kilometers per second. This celestial body, composed of rocky material, contained a significant amount of iridium, a rare element on Earth but abundant in the cosmos. In the moment of its impact, the world as the dinosaurs knew it came to an abrupt and violent end, reshaping the evolutionary path of life on Earth. In the aftermath, the resilience of life would be tested, and a new epoch would dawn, where mammals would rise to fill the void left by the mighty dinosaurs. 66 million years ago, a thin layer of iridium, discovered in sediment deposits across the globe, unveiled one of Earth's most profound mysteries, the mass extinction event that marked the end of the Cretaceous period. In the year 1980, physicist Luis Alvarez and his son, geologist Walter Alvarez, proposed a groundbreaking hypothesis. They suggested that a colossal asteroid impact was responsible for this cataclysmic event. Subsequently, in the Yucatan Peninsula of Mexico, a massive impact crater known as Chicxulub was discovered, measuring approximately 180 kilometers in diameter. This crater became the undeniable evidence that a gigantic cosmic body had collided with Earth 66 million years ago. The asteroid, descending at an angle of about 60 degrees, tore through the atmosphere in mere seconds, transforming the air before it into searing plasma, reaching temperatures of several thousand degrees. Creatures within several hundred kilometers of the impact site faced instantaneous annihilation, either incinerated by the thermal radiation or obliterated by the shockwave. The asteroid struck the shallow continental shelf of an ancient sea, penetrating Earth's crust and launching vast quantities of molten debris skyward. The energy unleashed by this impact dwarfed the combined power of humanity's most formidable nuclear arsenal. Within the initial moments, a transient crater 30 kilometers deep arose only to collapse partially upon itself. Molten rock fragments were ejected beyond the atmosphere, tracing ballistic arcs and blanketing the globe. As these incandescent fragments re-entered Earth's atmosphere, they ignited the air, spawning wildfires that ravaged continents. Scientists estimate a monstrous tsunami, towering up to 300 meters, surged onto the shores of surrounding seas, decimating coastal ecosystems and reaching hundreds of kilometers inland. Evidence of this catastrophic tsunami has been unearthed by paleontologists in deposits along the ancient Gulf of Mexico's borders and even in far-flung regions. The impact unleashed seismic tremors exceeding magnitude 11, reverberating across the planet, reshaping landscapes and triggering landslides. Some researchers posit that these seismic waves may have intensified volcanic activity in the Deccan Traps, creating a deadly synergy that compounded the apocalyptic conditions for life on Earth. The aftermath saw the atmosphere choked with dust, soot from widespread fires, and sulfur aerosols, casting a veil over the sun for months. This phenomenon, known as an impact winter, plunged the planet into darkness and cold, disrupting photosynthesis and collapsing ecosystems. Thus, through a confluence of cosmic and terrestrial forces, the stage was set for a new era, where the resilience of life would be tested and the delicate balance of Earth's biosphere forever altered. A cataclysmic chill swept across the planet, plunging temperatures by 10 to 15 degrees Celsius. This drastic cooling heralded the cessation of photosynthesis, a process vital to life, leading to the widespread demise of plant life. In the wake of this botanical extinction, hinds, once robust, call themselves bereft of sustenance, their survival strategies rendered obsolete. Acid rainstorms, laden with sulfur and nitrogen compounds, further ravaged the remaining vegetation and poisoned freshwater reservoirs across the globe. The oceans, too, were not spared from this environmental upheaval. The acidification of ocean waters decimated plankton populations, the foundational building blocks of marine food webs. As plankton vanished, so too did mollusks, fish, and their eggs, all of which were directly or indirectly reliant on these microscopic organisms. The ammonites, resilient survivors of numerous mass extinctions over hundreds of millions of years, met their final end, vanishing completely from the annals of life. Mosasaurs, plesiosaurs, and other formidable marine reptiles that once dominated the Cretaceous seas could not withstand the collapse of marine ecosystems. Pterosaurs, the last of the winged reptiles, also succumbed, ceding the skies to their avian relatives who would evolve into the birds of the modern era. On land, the catastrophe annihilated all non-avian dinosaurs. From the colossal titanosaurs weighing up to 70 tons to tiny predators no larger than a chicken, none were spared. Scientists from across the globe have long debated the exact nature of the dinosaurs' final day on Earth. Crucial insights into this epochal event were gleaned from a singular paleontological site known as Tanis, located in North Dakota, USA. Excavations at Tanis uncovered a layer of sedimentary deposits laid down in the immediate aftermath of an asteroid's calamitous impact, preserving the final moments of the Mesozoic era. Within these deposits, fish were found with glassy tektites lodged in their gills, formed from molten rock ejected into the atmosphere during the impact, sedimentary layers worldwide, serving as a definitive marker of the boundary between the Cretaceous and Paleogene period. At Tanis, the fossils of dinosaurs, turtles, fish, and plants were unearthed, seemingly perishing on the very day of the cosmic disaster. Sturgeons and paddlefish, entombed by sediment and buried alive, have been preserved with astonishing detail, a testament to the cataclysmic forces that reshaped the world millions of years ago. This moment in time, encapsulated in stone, offers a poignant reminder of the fragility of life and the inexorable passage of time, urging us to reflect on the ever-changing tapestry of Earth's history. The rivers and lakes near the excavation sites transformed into a churning concoction of mud, debris, and tektites, obliterating all forms of life. Picture an ordinary day in the late Cretaceous period. Herds of Triceratops grazed peacefully on the plains, consuming low-growing flowering plants. The Tyrannosaurus rex, the largest terrestrial predator of its time, patrolled its territory, stalking weakened or juvenile herbivorous dinosaurs. In the heavens above, pterosaurs of the genus Quetzalcoatlus, with wingspans reaching up to 12 meters. Small mammals hid within burrows and among the roots of trees, leading predominantly nocturnal lives to evade the attention of predatory dinosaurs. Yet, on this day, the sky bore witness to a singular spectacle, a bright point that, within mere moments, morphed into a blinding fireball, outshining the sun itself. The impact occurred instantaneously, and creatures thousands of kilometers from the epicenter had no time to comprehend the unfolding calamity. First came a flash of unbell in its path. Forests within a radius of 1,500 kilometers were felled and ignited by thermal radiation, transforming into endless blazing wastelands in mere minutes. The animals that survived the initial impact faced even grimmer consequences in the days week. Darkness enveloped the planet, lasting anywhere from several months to 2 years, according to various estimates, completely disrupting natural cycles. Temperatures plummeted, and the tropical forests that covered much of the land during the Cretaceous period began to perish en masse from the cold. Large dinosaurs, requiring vast amounts of food daily, were doomed to starve in a world devoid of green plants. Even those that survived the first weeks of the catastrophe could not find enough sustenance to maintain their massive bodies in the devastated ecosystems. Paleontologists estimate that approximately 75% of all species on Earth perished as a result of this monstrous cataclysm. On land, no animal weighing more than 25 kilograms survived, explaining the complete extinction of all large, non-avian dinosaurs. Nonetheless, some groups of organisms managed to endure, capitalizing on their small sizes, secretive lifestyles, or unique adaptations. Small mammals, hidden in underground burrows, survived the shockwave, fires, and prolonged winter by feeding on seeds and insects. Crocodiles and freshwater turtles endured by their ability to go long periods without food, taking refuge at the bottoms of water bodies. These survivors, resilient and adaptable, would become the progenitors of a new era, a testament to life's tenacity and its relentless march through time. In the wake of devastation, life finds a way to persist, adapting and evolving, forever weaving the intricate tapestry of existence. In the annals of Earth's history, the Great Extinction event at the boundary between the Cretaceous and Paleogene periods stands as a monumental turning point. Among the survivors of this cataclysm were certain avian species, direct descendants of small theropod dinosaurs. These resilient creatures not only endured, but also laid the foundation for the vast diversity of modern birds that grace our skies today. Reptilian life, too, found ways to persist. Snakes and lizards, with their secretive lifestyles and ability to enter states of torpor, navigated through the bottleneck of this mass extinction. Beneath the ocean's waves, life clung to the shadows. Deep-sea organisms, independent from the sun's nourishing rays, continued their quiet existence. Certain species of sharks and bony fish also managed to survive the turbulent seas of this era. As the dust settled and sunlight once again kissed the surface of the Earth, the painstaking process of ecological recovery commenced. Ferns were among the first to reclaim the ravaged landscapes. Their spores, capable of lying dormant in the soil, sprang to life when conditions permitted. This era is marked in the fossil record by the so-called fern spike, a testament to their sudden proliferation. In time, angiosperms, flowering plants, began to emerge, gradually assuming a dominant role in the verdant tapestry of Earth's rejuvenated ecosystems. Freed from the shadow of the dinosaurs, mammals embarked on a rapid evolutionary journey, seizing the opportunity to fill vacated ecological niches with remarkable speed and diversity. Within a few million years, the planet witnessed the rise of large mammals alongside the ancestors of modern primates and hoofed creatures. Birds, too, capitalized on the absence of pterosaurs, expanding into the skies and evolving into a plethora of flying and flightless species that spanned the globe. The extinction event remains one of the most scrutinized chapters in Earth's history, captivating scientists worldwide. Contemporary research harnesses the power of computer modeling, geochemical analysis, and cutting-edge dating techniques to reconstruct the precise chronology of this epochal period. Debates persist between proponents of the asteroid impact hypothesis and advocates of the volcanic activity theory. The majority of scientists today acknowledge the significant roles played by both phenomena. Some researchers suggest that without the preceding volcanic activity of the Deccan Traps, the asteroid's impact might have been less devastating to the biosphere. Others assert that the asteroid was the decisive force, with volcanism exacerbating an already catastrophic scenario. Regardless of which factor bore the brunt of responsibility, the outcome was equally devastating for the reigning dinosaurs and marine reptiles. The demise of the dinosaurs marked a profound tragedy in the chronicles of life on Earth. Yet, paradoxically, it also paved the way for the flourishing of mammals, heralding a new era in the planet's evolutionary saga. In a world dominated by colossal reptiles, our distant ancestors were but small, nocturnal creatures, living in the shadows of giants. Paradoxically, it was the cataclysmic impact of an asteroid 66 million years ago that paved the way for the emergence of Homo sapiens. The extinction of the dinosaurs serves as a poignant reminder of life's fragility and the vulnerability of even the most formidable beings to oblivion. Today, scientists delve into the Earth's ancient layers, unearthing fossils that whisper tales of the Mesozoic era's final days. Each discovery sheds light on the grand catastrophe that ended the reign of dinosaurs, marking the dawn of a new chapter in the saga of life. This study not only enriches our understanding of the past, but also equips modern researchers to assess cosmic threats, guiding the development of planetary defense systems against potential asteroid impacts. The demise of the dinosaurs remains etched as one of the most dramatic and instructive episodes in the chronicles of our planet. It is a testament to the ever-changing nature of life on Earth and the relentless march of time, urging us to reflect on our own place within this vast, interconnected web of existence.